Hello guys, so right now we're gonna discuss the three remaining bitwise operators. We have already discussed the first three types. The first one is the AND complement AND operator, and the second one is the OR, and the third one is the XOR. And now we're gonna discuss about the bitwise complement operator, and also the fifth one, which is the shift right operator, and the last one is the shift left operator. So these are the last three types of the bitwise operator. And first things first is we're gonna open up we're gonna first open this one so that I could be able to explain to you as well as the same as what we have created in the previous tutorial. So I'm just gonna open this one. So right now we can open this, create a sheet for this. And now we're gonna discuss this first operator that we will tackle this time, and that is the complement. And the complement has a symbol of this one like that, and that's what we call a tilde, and that's the name of the character, and it's beside with a number one key on your keyboard. And the meaning of this complement is that whatever you have created, for example, you have a value of 3, then this value we all know that it has a value of binary number, which is 000 and 0011. For this is 1 and this is 2. So when you add the two numbers, it becomes 3. And this complement here, we all know that meaning of complement is that it is the opposite one, or the different number or value of the binary numbers that you have in your variable or in the value. For example, this 3, the complement for this one is of this value here, which is 1, is 0, and then the other one is this one is still 0, and then the rest would be 1. So that is how the complement works. And complement has only one operand. That means to say that it cannot be compared to other value from this value. So that means to say that it has only one value, one operand. So there's no operator that could be used. Rather, this is the only one that could be used in just a single value. So this is the single value of the complement. So as we all know that this one, the value for this is big enough compared to this one, and the value for this is equal to 220. So that's what is the opposite or the complement of these three. However, there is sorry, it's not 220. Let me try to check if what's the value of this one. So this is 2 to the power of 0 plus 2 to the power of 1, and then this is to the power of 2 plus this one is 2 to the power of 3, and this one is 2 to the power of 4, and this one is 2 to the power of 5, and the last one is 2 to the power of 6. So this 1 here is when you add all of this 2 to the power of 6 is, we're gonna use the calculator for this. So 2 to the power of this exponent for this one is 1 to the power of 6 is equal to, sorry guys, and this one 2 to the power of 6 is 64, and this 2 to the power of 5 is 32, and this one 2 to the power of 4 is 16. I will not use calculator anymore because we know what's the sequence for this one. So, and 2 to the power of 3 is 8, and 2 to the power of 2 is 4, and 2 to the power of 1 is 2, and the 2 to the power of 0 is 1, right? However, this value here is 0, so that means to say that it is not part of this solution. So we're gonna erase this one and this one. So when we try to gonna solve this one, so let's use now the calculator so that it's much faster. So this one here is 16 here, and then 8 here, and then the 4 here, and 2. Oh, sorry, there's no 2 already. So that's all. So it is 124. So the right complement for this is 124, the value of decimal numbers. So this is the answer for the complement of 3. However, there is a twist. There is a twist in C programming language. There is a twist in C programming language, which means to say that the result of the complement of this value of 3 is not 124 anymore. However, it gives the complement of a 3, which is a negative. However, it becomes it is being added by 1. So this 3 here would become a negative, and then it's not 3 anymore, but it is being added by 1. That means it becomes 4. So that's how the complement operator works in C programming language. So instead of 124, it is not 124 anymore, but it becomes 3 plus 1, and with the open close parenthesis multiplied by a negative sign, so it becomes -4. So this is the formula for that. The formula for that is this one. It is the complement of 3 is negative and being multiplied with open close parenthesis with the number of your value and added by 1. So it's added by 1. So therefore, since n is equal to 3, so therefore this negative this minus is being put in the outside of the parenthesis, and then we're just gonna replace 3 by n by 3, and then add it by 1. So it becomes like this. So it is added by 1, so it becomes negative, and open close parenthesis 4, so it's being multiplied by negative 1, so it becomes negative 4. So the answer for that is negative 4. So that's how the complement of 3 in the C programming language. So let's try to check if it's really true. What I have made is really the right answer for that. So let's try to replace this 3 here, this value of the variable a, replace it with this. We're gonna put with 3, and then we're gonna call out this output function, which says that it is and bit level of the bit level operator x, or should be replaced by complement has this value. It's gonna create some new terminologies for that. And then this %d, as you can remember, it is the one that gives an output from this. So this format specifier is it specifies the value or the type of the value inside of this, which is the output of what is the compiler being what is being calculated or being solved, or the final output or the answer of the compiler of this operator, because we are trying to tell the compiler that, compiler, please give us the complement of a, which is the value of a is 3, and then this symbol here, this symbol here is the symbol of a complement that we ask for the compiler to express our words or our actions or our program to them, that they will do this one. So this symbol will help the compiler understand what we are trying to tell her or to tell him, in order that he could solve our problem or our assignment that we have assigned to him. So that's it. And the answer for that is, let's try to Control S, and then Control Alt and or click this, or right click and then click this first row here in our screen that says that run code, or Control Alt N. So as you can see in here, it says that the bit level operator complement has this value of -4. So the -4 is the answer for this. So we have solved this one here, as you can see in here, that the answer is -4. So we are right. We're correct in our solution in solving it. Instead of it is 124, it's not 124, but it becomes -4, because the formula of the complement in C programming is different from the complement that from the standard or from the conventional way of solving the complement. So the C programming has this kind of formula on how to get the complement of the value of a decimal number. So that's it, guys. So, and now let's proceed to the next type, which is the shift right. It is the shift right bitwise operator. So this shift right bitwise operator is very simple, guys. So this bitwise operator is shift right is it shifts the number of your binary number to the right. If you are trying to tell or giving you try to give an assignment to the compiler that you move the digits to the right in a one digit only. So that's the time that the compiler will gonna move the binary number at the right position. Just for example, for this one, for example, this is 3, right? So if we will move this, I feel there is the binary number value of 3 is this one, right? So if you try to let the compiler move this one, so it's just like this. Let's gonna put the symbol, which is the arrow, which is going to the right, and then if you want to move it in a one digit only, just leave it like that, and then the compiler will gonna move this one here to this one and replace this 0 to 1, and so on and so forth with this one. So the result for that would be like this: 0 0 0 0 0 1 1. So this one is being omitted already because it's this one here is being moved, and this one is also being moved here, and also this one, so on so on and so on and so forth. So the value for that would then becomes, I'm sorry guys, it's that the 3 value is just like that. So this one here, the 0 0 1, will become like that already. So the 1 here will be omitted. So that one there will be omitted, and then it will, and so on and so forth with this one. So this will move there, so this one will come, the result for that would since it's being moved, it will become like this. So the result would be this one, and then it will become a value of 1. So that's how it works. And then if you will try to move this with, for example, 3, you want to move it with 3 digit numbers from left, because it starts because we start to the left, from the left, because we are going to the right. So this 0 here, this binary number here will move to 3. So this, all of this will be omitted, so the remaining will be like this: 0 0 0, and it will be like that because it's the same, because we are adding some 0 here, and then we're moving that one, this one here, we are omitting this one, so it becomes a 0 value. So that's how it works. And also it's the same with the shift left. So the shift left operator, we're gonna erase this one. Shift left, the shift left will become just like this. If you want to shift the 3 value to the right, so we all know that this 3 binary has this value of binary number. So this one, when we move it with 1 digit, so it becomes, this one here will move to here, from right to the left. So that means to say that there will be a 0 added in this portion or area. So the answer, final answer, would be like this: 0 0 1 0 1 1 0. So this one here will be added by a 0. So this becomes 0 1 1 0 already. And if we will move the binary number with a 3 digit as well, so this 0011 here will have a new 0 here with not only a 10 but it is already a 3, has a 30, and the result for that is it's like this: 0001 1000. So this one, these 3 zeros here is being added from this one, so it becomes 1000, and this in here, so this one here will be transferred to this one, so that's why it is 001100. So the answer for this is 4, and then the answer for this is 8 plus 16, so therefore it is 32. Am I right? Oh, 24 rather. So it becomes 24. So let's try to make a code for that. So we're gonna create this, and then shift left right, shift right, shift right rather, has this value of %d \n, and we're gonna put this one here. So let's try to check if it's the right answer. So we're gonna move it by 1, and then as you can see in here, since we move it by 1, so the answer is 1. So the same with the answer that we have in our tutorial. And also, if we want to move it by 3, so this has an answer of 0, so the value is 0. So that's how it works, guys. So you have to put a digit here on the how long is your movement or shift in the binary numbers that you have in your value. So you have to put how many digits you have to shift the binary number in order to have an output that is having no error. So that's how it is. And gonna create now lesser than, shift left, has this value. So as you can see in here, it has the answer of 6. So it's the same with our answer. It is 6, right? Oh, this one, I'm sorry, it should be 6. It's not 0. It must be 6 because this is 2 and this is 4. So 2 plus 4 is equal to 6. So that's what is the correct answer for this. And also here we're gonna move it by 3, so let's run this one and to end, and this it is 24. As you can see in here, it's 24. It's the same with our answer here, right? So it's 24. So that's how it works, guys. So thank you for this is all for the bitwise operator, and thank you for watching my YouTube tutorial, and I hope you have learned something new with this. And again, I see you to the next tutorials. So, and we're gonna discuss some new topics for the next videos that we have gathered. the topics that are new, and so you can be able to learn more about the C programming language. And see you to the next tutorials, guys, and goodbye.